Good morning, girls. How are you? I hope you are all doing fine. Okay, today we are going to do some extra questions about the previous lesson and starting a new lesson. So in page 949, I left for you question 7. If you remember yesterday, we talked about 4 kinds of angles. We talked about the F angle, which is corresponding angle theorem, and we took the alternate interior, and we took the alternate exterior, and we took the same side interior. And there was 2 others that we took in the previous lesson, which is the linear pair or the supplementary angle when they form a line, and the vertically opposite angle when they are in front of each other as in a scissor. Okay, in this question, he is telling you that if these lines were parallel, and he is telling you to find x and y and name the postulates and or theorems that are used to find the values. Girls, the name and postulates, he means that to tell him what kind of angle is there. Is it corresponding? Is it alternate interior? Is it alternate exterior? Whatever. To understand what's happening here, beginning from here, 36-degree, girl, is this angle in here. This small one in the corner. The 1 to 6 is this one, this obtuse angle in here. This angle, this is 1 to 6. For the 3x plus 2y, this is the 3x plus 2y, again, the smaller one in the corner. And then the 12x plus 2y actually is this one in here, because he is pointing to the line. Of course, it's not the line, and actually it is this one. It's going to be this one. It's not the one in the corner here. No, it is this one. Okay? Okay. So beginning by the very obvious one, these 2 lines are parallel, right? Can't you see a Z in here? Can't you see a Z in here? We have a Z in here. You remember the alternate interior always created a Z. The alternate interior, girls, always created a Z, right? I mean, when we had 2 lines like this, consider they are drawn well and they are parallel. And we had a transversal. I told you that these 2 angles are alternate interior, right? Actually, they form the letter Z. Whenever you see the letter Z, this is the letter Z. Whenever you see the letter Z, these 2 angles will be alternate interior. The same thing is happening in here. This is what I'm saying. The same thing is happening in here. In the book. These 2 angles in the corner, the 36 and the 3x plus 2y, both of them are in the corners. They create the letter Z. So actually they are alternate interior angle theorem. So using alternate interior, I can say that 3x plus 2y is equal to 36, right? So this will be my first angle. This will be my first angle that I know, which is that 3x plus 2y is equal to 36. 3x plus 2y is equal to 36. This is my first equation. Going back to the book, let's go back to our book. Okay, for the other angle, 1 to 6, can you see this line and this line? These 2 lines are parallel, right? And this is their transversal. So this line, or this angle and this angle are corresponding, this one and this one, because they create the letter F. Both of them are on the left side of the transversal and both of them are down the line. So this and this are corresponding. So this and this are corresponding because all of them are creating the letter F. This is parallel to this, right? All of those are parallel and this is cutting them. Since these 2 lines, you remember when we explained corresponding yesterday, we said both of them will be on the same side of the transversal. So actually all of them are on the left side, and all of them are down, not up. Not here, not here. No, actually all of them are down. So they are corresponding. So this is corresponding to this, corresponding to this. So I can say that 12x plus 2y will be equal to 1 to 6 using corresponding angle theorem. 12x plus 2y will be equal to 1 to 6. 12x plus 2y 12x plus 2y will be equal to 1 to 6 using what? Corresponding angle theorem. Corresponding angle theorem, okay? And the one up was alternate interior angle theorem. You can write it here. It was alternate interior. And then you have two equations. How can I solve them together? You remember we had four methods to solve equations together. We had the substitution way, we had the elimination way, we had the multiplication way. Here it's very easy. We can use the elimination way. If I did subtraction, you remember same side, subtract. Since y have 2 and 2, both of them have the same coefficient, so I'm going to do what? Same sign, subtract. So since let's subtract. I will subtract from here, subtract here, and subtract there. Or even it's easier if I put this underneath this, yeah, and to put the bigger coefficient there. It will be easier. I think it will be easier. So let's try to put it in here. Exactly here. Yani I'm going to put 3x, so minus 3 minus 3x, and then minus 2y equal minus 36. I'm doing subtraction. Yeah, let's do the subtraction. 12 minus 3 will be 9x. Plus 2y minus 2y eliminated, right? And then 1 to 6 minus 36. I think it's going to be 90. 1 to 6 minus 36 is going to be 90. Yes, equal to 90. If I'm using the elimination method, and this was eliminated. This here was eliminated. Those together eliminated. Now let's complete. 9x equal 90, and then I should do what? I should divide by 9. Divide by 9 in here. Divide by 9. And here I will divide by 9. So x will be a 10. You will find x equal to 10. And then how can I find y? I'm going to substitute in any one of here to find my y. So let's use the first one, for example. Let's use the first one, for example. So 3 multiply 10 plus 2y equal 36, right? So 30 plus 2y equal 36. So shifting 30 to the other side, so 2y will be equal to 36 minus 30, which is 2y equal to 6. Divide by 2, divide by 2, y will be equal to a 3. So I found x and I found y. X is equal to a 10, y is equal to a 3. Okay? Okay, very good. So actually it was easy. It wasn't hard, right? Just maybe you didn't understand how to differentiate, or how to exactly where is the angles exactly. Maybe you didn't understand where is the angles. But now it's okay. If I created two equations and then I solved them using multiplication, using elimination. Elimination was the easier thing for me. Okay, then we have to do some extra questions in here. I'm going to do so. I'm going to be in page 951. In page 951, let's solve question 3, beginning by number 3. Okay, as you can see, my angles is in here. Find, suppose that measure angle 4 is 82, find measure angle 5. طبعا nothing easier. It gets nothing, يعني, this is the easier question. What is the relation between angle 4 and angle 5? What is the relation between angle 4 and angle 5? Very easy, right? Angle 4, girls, and angle 5 are same side interior angle, right? And same side interior angles are supplementary. يعني angle 4 plus angle 5 should be 180. This is what I'm going to write. So angle 5, which is unknown, plus 82 should be equal to 180, right? So how can I find angle 5? Shifting 82 to the other side. So angle 5 will be equal to 180 minus 82. And then finding the answer on your calculator, I think the answer will be 98. So 180 minus 82, so the answer is 90. Which theorem did I use? It's better to name the theorem. The theorem that I used in here is same side interior angle. Just you write it, please. Same side interior angle. Okay, let's do question 5. Suppose that measure angle 3 was 1 to 2. Find measure angle 5. It's not easier than this actually. What is the relation between 3 and 5? There is the letter Z but flipped in here, right? 3 and 5 are alternate because they are opposite and they are interior angles. So it is alternate interior angle, and alternate interior angles are always equal. So in here we are going to write that angle 3 or angle 5 is equal to angle 3 equal to 122 degree by using which theorem? Alternate interior angle theorem. What do you think? Very easy, right? Okay, let's go now to question 9. We have to do question 9. Where is question 9? Question 9. Okay, let's go back to our book. Question 9 in here. Yes, use the figure to find the angle measures. Okay, again, measure angle 5 is equal to 69. Find measure angle 10. Find measure angle 10. Again, what is the relation between 5 and 10? What is the relation between 5 and 10? 5 and 10 are alternate interior. So angle 5 will be, angle 10 will be again 69. Using which theorem? The theorem of alternate interior. So this is what you are going to write here in number 9. So in number 9, in the same page, in number 9, you are going to just write measure angle 5 equal angle 10 equal 69 degree. Using which theorem? Alternate interior. Okay? Okay. And we still have to do some extra questions. We have to go to question, we still have question 16. We still have question 16. Okay, let's go to question 16. 16 is in here. Yes. In the diagram of the movie theater seats, the incline of the floor F is parallel to S. Yani F and S are parallel, and we can consider that these lines here are my transversals. Yani we can say that, for example, this angle and this angle is corresponding because there is a letter F. And this angle and this angle, for example, and in here, this angle and this angle in here are alternate interior, and so on. So for 16, he is saying, if measure angle 1, this one here was 60, find measure angle x. This is a good one. There is no relation between x and 1 right away. There is no relation between x and 1. But is there a relation between this angle in here and 1? Yes, there is a relation between this angle and 1. They are what? Both of them are on the left side of the transversal, and both of them are inside, or both of them are to the right, and both of them are down. So we can see that these angles are corresponding. Angle 1 and this angle in here are corresponding angles, and corresponding angles are equal, right? So this angle that have no name, we can name it anything. We can name it A, for example. Let's name it A because there is no name here, and actually we need a name. So let's name it A, for example. So let's name it A. Okay, where is it? Yes, let's solve in here. So we can say here that angle A, I'm going to name this small one in here, angle 8. So angle A is equal to angle 1 equal to 60 degree. Why? Because they are corresponding angles. Corresponding angles. Okay? Okay, and then if angle A is 60, angle A and the 3x are what? Both of them are what? Are linear pair. They form a line. Both of them should be 180 degree, right? So angle A plus 3x should, not 1 here, angle A plus 3x should be 180 degree, right? Why 180 degree? Because they form a linear pair. Linear pair theorem, right? They are linear pair. So 60, because angle A was 60, plus 3x is equal to 180. How can I solve this now? How can I solve it? I will solve it by shifting the 60 to the other side. So let's do it in here. Shifting 60 to the other side will make 3x equal to 180 minus 60 is 120. And then divide by 3, divide by 3, x will be equal to 40. So you found x. What is x? I found x. X will be 40. X will be exactly 40. Okay? Okay, by this we have finished our lesson. Okay, in the new lesson, lesson 19.3, the lesson is called Proving Lines Are Parallel. Proving lines are parallel. Take care what's happening now. In lesson 19.2, for all the theorems, the first line was in the theorem was always what? If line L and M are parallel, then these angles are corresponding. These angles are alternate. These angles are whatever. But the first line was always if these lines are parallel, so whatever. And he is already saying, and he is already telling you that these lines are parallel. That these lines are parallel. In this lesson, we are doing the opposite. You are doing the converse of the theorem. What is a converse? Converse means the opposite, the contradiction. Today, girls, in this lesson, we are going to be doing the opposite, which means instead of he telling you that these lines are parallel, so these angles will be equal, whatever, no, I'm going to ask if these angles are equal, so these lines are parallel. Yani this time you are trying to prove not that the angles are equal, no. You are trying to prove that the lines are parallel. If you are doing the opposite. The word of the converse, girls, the word converse means what? The word converse means what? Because we are going to be here listening this a lot. Converse means that when I tell you that if A happens, then B happens. This is a theorem. If A happens, then B happens. What happened first? or what is already happening, A is happening, right? Converse means that I will tell you if B happens, then A happens. This is the converse. Converse يعني you are doing the opposite. Here, what happened? What happened here that A first, then B. In here, the converse, I'm going to be doing the opposite. Here, B happened, then, يعني B first, B happened first, then A. يعني in other words, before, for example, the corresponding angle theorem, it was saying if L is parallel to M, وL ده is a line, for example. So if L is parallel to M, so angle 1 and angle whatever, angle 3 are equal because they are corresponding, for example. Now, I'm going to tell you, if angle 1 and angle 3 are equal because they are corresponding, so L is parallel to M. This is the new lesson. This will be our new lesson. You are doing the opposite. You are not trying to prove that the angles are equal because they are corresponding and finding the angles and so, no, you are trying to prove that the two lines are parallel to each other because the angles are equal. So this is our lesson today. You are doing the converse. This is called converse of the theorem. This is called converse of theorems. This is called the converse. Okay? Okay. Let's go back to our lesson. So in page 955, write the converses of parallel line theorems. You form the converse of and if then statement, if P then Q, by swapping P and Q, just like I explained for you. If A happened, then P happened. Now, to do the converse is going to be if P happened, then A whatever. Yani just you are swapping the two events. Instead of this happening first, no, this happened first. The converse of the postulate and theorems you have learned about line by a transversal are true statement in the explore whatever. Okay, let's see what's happening here. Lines L and M are parallel. If line L and M are parallel, angle 4 will be equal to angle what? 6, right? Or 8 even. Angle 4 will be equal to angle 6. Here he is using same side interior angle, yes. Angle 4 is equal to angle 6, yes. Angle 4 is equal to angle 6. Angle 4 is equal to angle 6. Okay. Angle 6 and angle what are supplementary? Angle 6 and angle 3 are supplementary. So angle 3 will be equal to angle 7 because they are corresponding. So here you are going to write angle 4 is equal to angle 6. Angle 6 and angle 7 are supplementary. So angle 3 is congruent to angle 7 because they are corresponding and because 6 and 7 are alternate together. Use the two of the given statement together to complete the statement about the diagram using the same side interior angle. By the postulate, if what, then angle 6 and angle 4 are supplementary, then angle 6 and angle 3 are supplementary. Yani why did we say that angle 6 and angle 3 were same side interior angle? Because what happened? Because in the beginning he told you that lines L and M are parallel, right? So the first thing, or the first event that happened was if line L and M are parallel, then angle 6 and angle 3 are supplementary. Why? Because they are same side interior angle. So this is what you are going to write in here. So in here, you are going to write if lines L and M are parallel, then angle 6 and angle 3 are supplementary because this is the same side interior angle. This is called, girls, the postulate. Now let's write the converse of the postulate. Converse means what? You are going to swap the two events. What are my two events that happened here? The first event is line L and M are parallel. The second event is angle 6 and angle 3 are supplementary. What happened first? That lines L and M were parallel. Let's swap them. Yani let's make the second event happens first. So if angle 6 and angle 3 are supplementary, then lines L and M are parallel. This is what I did. I swapped them. I brought this event here, which is angle 6 and angle 3 are supplementary first, and lines L and M came second. So this is called a converse of the postulate. Converse of the postulate. Converse of the postulate, as we said, means what? You are swapping the two events together. So if angle 6 and angle 3 are supplementary, then line L and M are parallel. This is called the converse of the same side interior angle. This might be asked from you in the exam. You have to understand that the postulate says if lines are parallel, then angle 6 and angle whatever are supplementary. The inverse of the postulate or the converse of the postulate, you do what? You swap the two events. Let's go to number 3. Repeat to illustrate the alternate interior angles and its converse using the diagram and the given statement. So again, if line L and M were parallel, so angle 4 is congruent to angle 6 using what? Using the alternate interior angle. This is what he wrote here. If lines L and M are parallel, then angle 4 and angle 6 are congruent. Girls, angle 4 and angle 6 are not congruent always. They are congruent because these two lines were parallel and this line cut them. If these two lines were not parallel, will angle 4 be equal to angle 6? Never. Never. They will not be equal. They are equal because they are parallel. So let's write the converse. What will happen to the converse? If angle 4 and angle 6 are congruent, then lines L and M are parallel. I swapped the event. I brought this and then this. I wrote this first. Yani here, this is the first, this is the second. In the converse, this will be the first that comes after the if, and this will be the second that come after them. In the same way, use the diagram to illustrate the corresponding angle theory. The first thing will be if lines L and M are parallel, then angle what is equal to angle 7 using corresponding angle 3 is doing the letter F with angle 7. So angle 3 is equal to angle 7. To write the converse, if angle 3 is congruent to angle 7, then lines L and M are parallel. So here, each time you are writing the theorem and its converse. Take care that all of the angles are theorem. Yani the alternate interior are theorem, the corresponding angle are theorem, only the same side interior are a postulate. Postulate. Okay? Okay. Let's go back. Let's go to the second page. In here, in the first page, we understood what does it mean to have a theorem and have a converse of the theorem. How do you form the converse of a statement? How do we form the converse of a statement? We swap what? We swap the two events. We swap the two events, or we swap the two statements. So this is what you are going to be writing. You swap the two events, or you swap the two statements. So for question reflect 1 in here, for reflect 1, we are going to write swapping the two events. We swap the two events. Okay? Okay. Let's go back to our book. What kind of angle 4 and angle 6 in step C? Angle 4 and angle 6 together are what? Alternate interior. So this is what you are going to write in here, alternate interior angle. Alternate interior angle. Just write alternate interior angle. It doesn't, I don't care for this. Just write alternate interior angles. Alternate interior angle for question 2. Alternate interior angles. Okay, explain 1. Proving that two lines are parallel. To prove that two lines are parallel, we will be having 3 converses. The converse of the same side interior angle postulate, and the converse of the alternate interior angle theorem, and the converse of the corresponding angle theorem. This is called a postulate. The only one which is a postulate is the same side interior angle. And then those are a theorems. Okay, let's read them. If two lines are cut by transversal so that a pair of same side interior angles are supplementary, يعني in other words, if two angles are supplementary and they are on the same side interior angle, so the lines will be parallel. If two lines are cut by, you don't need to memorize this or anything. No. Don't worry, just understand them. If pair of alternate interior angles are congruent, then the lines are parallel. For the corresponding, if a pair of corresponding angle theorem, corresponding angles, sorry, are congruent, then the lines are parallel. So those are the converse. Before, in the previous lesson, we took the theorem as it is. If the lines are parallel, then the pairs of whatever angles are corresponding and they are equal. Today, you are doing a swap. Okay, let's do exercise 1. Whatever you have this shape here, this is like a mosaic tile. Using quadrilateral shaped color tiles to make an whatever. Each tile is congruent to the one shown in here. Yani all of these tiles are the same. They have 120, 60, 120, and 60. Okay, use the values of the marked angles to show that the two lines L1 and L2 are parallel. Yani suppose that here, we have this here, this is 120, this is 120, this is 60, and this is 60. So in the same way, this will be 120, 60, 120, and 60. How can I prove that these two lines are parallel? How can I prove that these two lines are parallel? We have 3 theorems in here. You can use the same side, you can use the alternate interior, or you can use the corresponding. Let's see how to use all of them. Let's begin with the same side interior. When these two lines are the one I'm trying to prove they are parallel, where is the same side interior angles in them? The same side interior will be one of those. So for example, this and this, these are same side interior. Because in here, girls, this is supposed to be the transversal line, and these are the two parallel lines. So these are same side because they are on the same side of the transversal, and both of them are interior. So same side interior angle. Let's see, this is 60 and this is 120. Are they supplementary? Actually, they are supplementary because 60 plus 120 is 180. So a pair of same side interior angles are supplementary. So L1 is parallel to L2 using the converse of the same side interior angle. Oh, this is what he wrote in here. Measure angle 1 is 120, like in here. Measure angle 2 is 60. The two angles are supplementary. And the two angles are in the places of same side interior angle, right? So you prove that a pair of same side interior angles are supplementary, then the two lines are parallel. This is how to use the same side. Now let's use the alternate interior. This angle here is 120, right? Because it is the same as this. And this angle is 120, right? Because it is the same as this. And these two angles are in the place of which? What is the name of these two angles together? They are alternate interior. So I proved that two angles, alternate interior angles, are equal. So I can prove that the lines are equal, using which? The converse of alternate interior angle theorem. So let's talk about the corresponding angle. Right. This angle is what? 120. And this angle is what? This is 120 because it is the same as this. And this is 120 because again it is the same as this. And these two angles together are doing the letter F. So they are corresponding. But I proved that these two angles are equal. and these two angles are corresponding. So using the converse of corresponding angle theorem, I can say that these two lines are parallel. يبقى what comes first is that you are proving that the angles are equal. Then what comes next? That the lines are parallel. Okay, let's do question B. Now look at this situation. Use the values of the marked angles to show that the two lines are parallel. Angle 1 and angle 2 together, they form a what? Yani first of all, you have to think which angles are those. Are they same side? Are they alternate interior? Or are they corresponding? Or even are they alternate exterior? Which one of them? Angle 1 and angle 2, both of them are down the lines. L1 and L2, they are down the up. Sorry, this is not down. They are up. They are upper up the line, and both of them are on the left side. So these two angles are corresponding angles because they do the letter F, but this time it's a flipped F. So I will say measure of angle 1 is congruent, or what? Measure of angle 1 and angle 2. We are using the same tile, by the way. Angle 1 and angle 2 are the 120. They are the same as those. They are the 120, and the same for 2. So measure angle 1 is 120. Measure of angle 2 is 120. The relation between the two is angles are congruent, and the name of them is corresponding angles. So the conclusion, L1 will be parallel to L2 using converse of corresponding angle theorem. Yani this is what you are going to be writing. Measure of angle 1, 120. Measure of angle 2, 120. So they are congruent corresponding angles. So the conclusion is L1 is parallel to L2 by the converse of the corresponding angle theorem. What if, suppose the designer had been working with the basic shape instead? Do you think the conclusion in parts A would have been different? Why or why not? Yani he says, instead of using the 120, 60, 120, 60, he was using 110, 70 and 110, 70. Will anything change? Yani will the two lines will not be parallel? Actually, of course not. They will always remain parallel, because what? This angle will change, and this angle will change, and this angle, yani every angle will change, so that it will remain that yani this angle will become 110, and this angle will become 110, but in the same way they will still be equal. So the lines will still be parallel. So no, because the tile pattern formed still will be congruent. That can be used to produce parallel lines. Okay, let's go back, or let's go to the in here. For your turn, you are supposed to do this. You have to tell me how, which converse of angles 1 and 2 here are what, and 1 and 2 here are what. So you are going to write in here, since these two angles are whatever, yani for example, they are same side, they are alternate interior, they are corresponding. And since they are equal, because they are equal to 120, they are equal to 60, whatever, according to this style. So using the converse of whatever theorem, the lines L1 are parallel to L2. Okay, so I'm leaving 4 and 5 for you. Okay, actually this part, girls, explain 2 is cancelled. Okay, explain 2, which is constructing parallel lines, this page is cancelled, which is page 958. 958 is cancelled. And we are going right away to explain 3 in page 959. So all of this is cancelled till number 7. Using angle pair relationships to verify lines are parallel. Actually, it is the same thing. Use the given angle relationships to decide whether the lines are parallel and explain your reasoning. Actually, it is the same thing as explain 1. It's not new. Okay, he's telling you here angle 3 are congruent to angle 5. How can I use this to identify if my lines are parallel? He is telling you here, when he tells you that 2 angles are congruent, step 1 is to identify what is the relationship between these 2 angles and are they congruent or no. Let's see here. Angle 3 and angle 5. What are the relation between angle 3 and angle 5? They are what? They are alternate interior, right? So we discovered that they are alternate interior, and he told you that they are what? They are congruent. So angle 3 and angle 5 are congruent alternate interior angles. If I have two alternate interior angles which are congruent, so I can prove that line L and line M are congruent using which theorem? The converse of alternate interior angle theorem. Alternate interior angle theorem. So I discovered that the two lines are parallel. Okay, let's see what about angle 4, question B. Use the given angle relationship to decide whether the lines are parallel. And he told you here, measure angle 4 is x plus 20, measure angle 8 is 2x plus 5, and he already gave you x. He already gave you x. So first of all, before doing anything, I have to, since he already gave me x, I have to substitute x in here and substitute x in here to find my answers, right? So 15 plus 20, which is going to be, I think, 35. And then 2 multiply 15, which is a 30. 30 plus 5, again, it's a 35. So 35 and 35. They are equal, right? They are congruent, right? Let's go back to our diagram and see angle 4 and angle 8 are what exactly? Angle 4 and angle 8. Yes, this is what? This is the letter F. Angle 4 and angle 8. So they form a what? Corresponding angles. They are corresponding angles. So we can write, so angle 4 and angle 8 are congruent corresponding angles. Yeah, they are not only corresponding, they were congruent because both of them was 35, right? Both of them was 35. So they are congruent corresponding angles. So step 2, are the lines parallel? Since they are equal and since they are in the place of corresponding angles, so I can prove that lines L and M are parallel using the theorem of what? Using converse of corresponding angle theorem. Yes. So the lines are parallel by the converse of the corresponding angles theorem. Understood? So actually you only have 3 things. Either same side interior angle postulate, the converse of same side, or the converse of alternate interior, or the converse of corresponding angle theorem. You will not have anything else. Only these 3. Okay? Okay. So you are required to do question 8 and question 9 by yourself. Here he is telling you that 3 and 6 is 1/8. 3 and 6 are supplementary. As we said, step 1 is for you to identify what is the relation between 3 and 6. And then tell me, so line L and M are parallel using the converse of whatever. Which theorem you are going to choose? Either the alternate interior, is 3 and 6 alternate interior? Are they same side interior? Are they corresponding? You have to tell me. And then he is telling you here, if angle 2 and angle 6 were congruent. So what will happen? Which theorem you are going to choose? Okay, so you have to do number 8 and number 9 as well. Okay, our lesson is done. Thank you very, very much, and have a nice weekend. Of course, you have to go back, girls, each time to the Class Dojo post. On Class Dojo post today, you will find me leaving you some pages, solving some old questions that I was leaving for you, and as well as what should you do exactly, what will be your homework, what will be your classwork. So please, after finishing your video, you have to go back to the Class Dojo post to see our guidelines exactly. Let's see you.